So as promised in the previous video, it's now time for a mini challenge. But just a point before we start, don't spend more than a minute or two thinking about this one. It is designed to be just something you should hopefully just sort of get off the top of your head, so don't spend, again, too much time on it. So the challenge here is looking at the way the last two examples have been coded, generally, what is the difference between the approach taken here and all the previous examples we've used prior to that in this course. So have a think about that and come back when you're ready, and I'll give you some more information about that. Okay, welcome back. The answer simply is there's no real difference at all. So these two examples use classes, but apart from the fact that I wrote the classes in the programs, there's no real difference to the methodology that we've employed here. So in other words, if the song, album, and artist classes had been part of the standard library, then there's nothing to distinguish the approach here from anything else that we've done so far. So this program uses objects, but it's not object-oriented programming. So object-oriented programming is not just about classes, it's a different way of thinking about problems and results in a different program design. So it uses classes and objects for sure, but it also includes important concepts such as encapsulation, composition, inheritance, and delegation. Now I've discussed encapsulation at the start of this section, and we're going to be looking at inheritance and composition in later videos. Delegation, on the other hand, involves passing on responsibility for a task to another object that's better suited to deal with it, and it's fairly, it's really closely tied to encapsulation. Now, for example, we've encapsulated data in our classes, but we haven't really encapsulated methods very well. There's an add song method in the album class and an add album method in the artist class, but that's really it. These two methods were included because the relevant classes own the lists that they'll be added to, so it seems quite natural that the artist class should be responsible for adding album objects to the list. But this only considers the data. There's been no attempt to encapsulate the functionality of the program. Encapsulation involves encapsulating data and methods, not just data. So we really need to make some changes to turn this into an object-oriented program rather than just a program that happens to use objects. Then there's obviously an important distinction between those two. So encapsulating methods means considering questions such as which object is best suited to dealing with this task, or where does responsibility for performing this function belong. So relating this to the real world, if my car breaks down, I'm going to look for someone who encapsulates the knowledge of how to fix it, a mechanic in this case. So my local mechanic has been programmed by attending college perhaps with the knowledge necessary to fix a car, so I'm going to delegate the job to him or her. Similarly, if I want an extension on my house, I'm not going to try and build it myself. I'm going to find someone who's got the skills to do this for me. And that's of course unless you're a builder. A builder encapsulates the skills required to build something that won't fall down or leak in the rain, and consequently I'll delegate that task to them. So relating this back to our program and looking at our load data method, I'll just bring that up on the screen. That function's doing all the work of parsing the data and working out what to do when it finds a new album and a new song. Really though, the object that knows the most about albums is the artist, and albums know all about songs. So we really should encapsulate the methods for dealing with albums in the artist class and for dealing with songs in the album class. So once that's done, load data can delegate dealing with this to the appropriate class. So I'm going to start by rewriting the load data function to delegate most of the work to the artist class. Now when doing this, I'm going to be calling methods that haven't yet been written. Now this may seem an odd thing to do, but an object-oriented approach means you don't have to worry about how something's done. You focus on the fact that you need it to be done, and something else will be responsible for getting it done. So that will make more sense when you see the load data code. So let's go ahead and do that. So the first thing we want to do now with load data is we're going to delete this first bit of initialization code. We no longer need that. So delete those 3 lines there. Or to be precise, just delete those first 2. We want to leave the artist underscore list. We still will need that in this revised method. Now what I'm going to do is even though it's going to involve some code that already exists on the screen, I'm going to delete it and retype some of this in just so you can see sort of much easier what's been changed. So I'm going to leave the with code. So we're obviously initializing the list on line 92. This basic code here that retrieves the data from albums.txt, that's not going to change, and we're still going to leave that printing out. But after that, I'm going to remove all that code and delete it because we can substantially reduce the amount of code here. So I'm now on line 101, and we're now going to process each entry that we're receiving or getting from the albums.txt file. So I'm going to do new artist equals find object. It's going to be artist field artist list. So we're looking for the artist based on the name attribute, which we talked about extensively in the last video. And if the new artist is none, set to none, meaning that we weren't able to find it in the list already, then we're going to create new artist. It's going to be artist field. So we're creating the new artist object. Then we're going to do artist underscore list dot append new artist like so. And then we're going to do new down here, new artist dot add song. It's going to be album field, year field, and then song field. And that's it. So the first part of the function is unchanged. The artist class isn't interested in the fact that data is coming from a text file, nor is it interested in the fact that it's read as a tab delimited list. And so load data as a result continues to be responsible for reading the data and splitting it into the correct fields. Of course, that's the code from line 94 through 98. The list of artists belongs to the main program, so load data also retains responsibility for creating a new artist object after checking that one doesn't already exist with the code here on line 102. That's all it does though. Everything else you can see now is delegated to the artist class by calling its add song method on line 106 and then providing it with the fields, the remaining fields, the album field, the year field and the song field, so that it can go ahead and create that. But at this point, we're not interested in how the add song method will work. I know that the song will need to be added somehow, but the focus here is on dealing with artists only. I'm going to worry about how add song will function when I get around to coding it. Until then, I'm just going to call it and not worry about it. So it might seem strange calling a method that doesn't exist, and of course the program won't work until it does exist. But if you think about it, it's really no different from delegating the repair of a car to a mechanic. In other words, I don't need any idea of what the mechanic will do. I don't need to be a mechanic. I don't need to understand how to fix a car. I just know that the car needs fixing, so I can call my mechanic and say, fix the car. And I do say hello first and please afterwards, of course, but basically, when it boils down to it, I'm calling my mechanic's fix_car method, and hopefully, I'm pretty confident that when the car returns, it will be fixed. So I'm sure you will agree that looking at this code now, it's far simpler than our previous version. As a result, much easier to understand. And in fact, creating a flowchart for this would probably be totally over the top, because the code that we've got now in our load data function, pretty much documents itself. So now that the main program has been written, it's time to focus on the details of that add song method that we're calling on line 106. So what we'll do is we'll create that method first and then explain what it's doing. So let's go back up to the artist class that we've defined, the code for that. We're going to add this method now, this add song, after the add album method. So let's add it here. Let's make a bit of space there. So I'm going to start with creating the new method. So add song is going to be what it's called. And we've got a self, obviously, parameter. And then we've got name, year, and title. And just for a comment, we're going to add a new song to the collection of albums. Albums, and let's just document it and let's go into a bit more detail. So this method is going to add the song to an album in the collection. And a new album is going to be created in the collection if it doesn't already exist. And the arguments, args, name, which is going to be a string, and that's obviously the name of the album. Our second parameter is year. It's going to be an integer, and it's obviously the year the album was produced. And the third argument, title, which is a string, and then the title of the song. Title of the song. Okay, so that's our doc string for this method. So let's start by writing it. So I'm just going to move this up a little bit so we can see a bit more on the screen. So we're going to start, actually, I'll type it out, then we'll talk about it a little bit more. So album underscore found equals find underscore object. And the parameters for that are going to be name, which was an argument to this method, and self.albums, which is obviously an attribute in this class for the list of albums. And same sort of test here. So if album underscore found is none, meaning the album doesn't exist in our song and our albums attribute, then we'll just print a message to indicate that. So we'll put name not found, and then we'll put album found is equal to a new object for album name year self. Then self.add underscore album underscore found. Again, we'll talk about this code shortly. Otherwise, then else, we're going to do print, and the opposite happened. We found the album, so print album plus the name, because that came back as came back from the find object method. And then in both cases, it's going to be album underscore found dot add underscore song title being the name of the song. Okay, so hopefully the doc string that I added on line 82 really says all that needs to be said. So add underscore song uses the name of the album to check if an album is already present in the list of albums, and then creates a new album if it isn't, or if it doesn't exist. In other words, if it's not present in the list of albums. Anything else that needs to be done is then delegated to the album class add song method. Now the artist class knows about albums, so it deals with the album part. It doesn't know about songs. That's left to the album class to deal with. Once again, I don't care what the album class's add song method does at this stage. I just know I'm going to call it and let the album class handle what happens. And you saw me add print statements here so that we can see what's happening when we come to run the program. But the rest of the code, once again, pretty much documents itself. So I'm going to finish the video here now. And I don't know why I added a semicolon on the end there, by the way. Wrong programming language. So as I said, I'm going to finish the video here now. In the next video, we'll come back and we'll implement the album class add song method so that we can delegate the task of dealing with the song to that method. So see you in the next video.